Okay, everyone, welcome to today's brown bag lunch. It's pure functions and immutable objects, the best of OO and FP worlds. And I'll introduce to you, Victor.
Thank you.
Please, let me see if I should just, yeah, has everyone seen Victor? Well, I can spotlight you, but it's fine. Go ahead, Victor.
Good. So, pure functions and immutable objects. Again, feel free to have a lunch. Feel free to ask questions whenever you want. I'll keep an eye. Just me open my chat. Yeah, there you go. So, I would like to ask you folks just a quick question. How many years of experience you have in coding? Just a number, an integer, please. How many years, in order to better tune the presentation.
So
in the chat,
bombard the chat.
Bombard the chat with your experience level in years, right? I want to see how deep should I. Oh, wow. All right, let's do this. So, my name is Victor Rentea. I'm a Java champion. I love simple design, refactoring, 305. Simple design, refactoring, and unit testing. I founded a community where I invite you also to join. It's called Bucharest Software Craftsmanship Community, exactly focusing on simple design, refactoring, and automated testing. I've done hundreds of events here. The next one is what? Tomorrow? Oh my God. Designing expressive and performance persistence model with GPA, stealing ideas from domain-driven design. So very interesting how the tactical patterns from this, from DDD basically. It's now in the chat if you want to join, completely English, completely free. Right. I have a website on which I have a playlist of my best talks. Some of them were ranked in the top 3 at different conferences. I also have an incipient blog and other goodies on my site. And what I do for a living, I do trainings and consultancy. Right before you today, I had the first round of training with someone from Switzerland, with a group from Switzerland. So that's what I do for a living. The standard stack with Java, Spring, Hibernate functional programming, reactive programming, Java performance, pragmatic domain-driven design with focus on pragmatic. Interesting. Unit test. Now yeah, DDD can be misinterpreted, can be over-engineered dramatically, can kill a project with over-engineering. But anyway, if you want me for your company or for yourself, check out my website. I'm also on Teachable, doing webinars. On Thursday, I do memory leaks on Teachable. So if you want to join individually, find me there. Right. So I will skip to the slides because I want to keep in 40 minutes so that I will leave more. But again, any question you have, shoot. Let's turn back time. 26, 27 years ago, one smart guy, Bertrand Meyer, had this idea about functions, that a function should be either a command or a query. Now, to understand the idea, if a function returns void, the only reason why you would ever call it is, of course, for that function to do side effects. You definitely don't call the function to get the void back. It's a void, right? So you want the function to do stuff. There you go. So everyone expects that the function returning void will change something in the universe. Will change a field, will persist something, will do stuff. However, do you remember the time in which we used to fly? Do you remember the time? I was a frequent flyer. So I'm so in love with flying. However, today, after COVID, the feeling with flying is at most the following. This is us flying today. Let me load Twitter here. Come on, front end, back end. I'm not sure if you are. Yes, so this is how we fly today. However, remember the days in which we used to fly. And if you ever flew a low-cost airline, you may have had the following scenario. Imagine I was searching for a flight in the morning and I saw a price. I had to talk to my wife and see whether it's okay or not, blah, blah, blah. And in the evening, we wanted to book the flight. And guess what? The price was higher, of course. It's a low cost, right? So this is very annoying to find for the same flight a different price. People don't expect that. People get frustrated because given the same argument for a function, they kind of expect they get back the same results, kind of. On the other side, if you search for someone on Facebook, on Facebook, on Facebook. Do you expect that your search is being persisted in 7 systems? We expect that, we are developers, but normal people don't expect that their search is being inserted somewhere. So what I want to say here is that when you call a function that returns you results, you typically don't expect that you will get different results the next time you call it with the same arguments, nor do you expect that you cause some changes in the universe with your query, with your demand for data. So in other words, functions that return results, Bertrand Meyer thought they should be pure functions, and we love pure functions. Pure functions have 2 attributes, the one that you just saw. They don't change anything when you call them. Okay, you are not supposed to insert, to do any post, any message on queue, any file, not even changing a field. And this is blood draining from here. Not even changing a field is allowed from a pure function. And then some inputs, and basically what a pure function does is just computes the outputs. And if you give it the same inputs, it will give you the same output every time. The geek word for this is referential transparent. It means it can't rely on the current time or random, although these don't give us lots of headaches. What gives us problem are fetching of data from outside world, like selecting or getting. A select is not pure, because if between 2 selects someone inserted a row, of course you get more results. So there you go. The best analogy for pure functions are mathematical functions. You just compute stuff based on your inputs. Okay. Right, now to cut to the point, I will skip some things here. If a function is pure and fast, did I mention I am a clean code maniac? I think I did. I am really addicted to refactoring, right? If a function is pure, typically it is also fast. Why? Let me come back to this description. Well, every time you exit the system to fetch data, you are not pure. You are depending on some externals, on some external data, which can change between your calls. Every time you change stuff outside, of course, you are not pure. So, but I want to focus here. Doing a get or a select from somewhere is not pure. So a pure function will not talk to network. And the network is what bottlenecks most of our applications today. But network is where latency happens. So a pure function is almost always fast, very fast. So if a function is pure and fast, then it is safe to call it any number of times. So this allows us for a very interesting refactoring, like the following. We have a variable defined here, used in 2 places. If this function is pure, you can safely replace the variable with a function call. You see what I mean? Inlining a variable. Super useful in practice to be able to juggle like that with your code. Okay, so inlining a variable becomes entirely safe if your function is pure and fast. If it wasn't fast, calling it twice, it will cost time, right? Interesting, very interesting. So pure functions are good. Pure functions are good because they don't have hidden inputs. They don't bring data in the system from anywhere else. They just rely on input values and parameters. And there is no hidden temporal coupling. We didn't mention this, but just the life is this. In real life, you have 2 lines of code, and you move this line earlier. Did you ever had a bug because you reworded 2 instructions? Just move the line, boom. What happened? This line actually activated the customer, and check order expected an active customer. If you move it there, boom. This is called hidden temporal coupling between these 2 methods. They need to happen in that order, otherwise, kaboom. There is no such thing with pure functions because they don't. The only way they can depend on one another is the output of the first function to be passed as the input to the second one. There is no other way they can depend to each other, but only through the arguments, which is very cool. And you know what the best part of pure functions is? You don't need mocks to test them. Oh my God, no mocks, no mocks, no mocks. Yeah, so those tests with 7 when then, and 3 verify, gone with the wind, gone. No more. Input, output, very good, very easy to test. Okay, and also easy to refactor, as I mentioned. Right, so the point is that you don't care how many times and if you call a pure function. That's what you aim for. Developer. Pardon, senior developer. Let me explain. coming back to this example here, when you inline the function twice here and here, it is safe now because f is pure. But in my trainings, many seniors tell me, but what if a colleague of mine inserts something from that line, from that social? You can't really get clean design and clean code without trusting each other, right? Without having a common, let's say, standard, quality standard. I mean, if you would do an insert in that function, wouldn't that sun on the beach, test that function at least once? I mean, probably it should be in the culture that you test your stuff, right? So indeed, there is a risk in there that the function becomes impure tomorrow, but you should fix that by fixing the culture, really. So pure functions are good, so let's make everything pure. It's not that easy because your system has to change stuff. Your system has to persist stuff, has to generate some files, has to do something. So then what's the purpose of pure functions in real life? Most of you probably heard of pure functions based on your experience level, but the use of pure functions is right in the middle of a complex logic, in the center of a complex logic, in the middle of a very, very nasty, full of ifs and rules. There in the middle, you should try to isolate a functional core. A functional core composed solely of pure functions. Easy to reason about, easy to understand, easy to test. Yeah, no mocks. So then that functional core in there will be surrounded by an imperative shell in which you will push all the nasty queries, inserts, all the side effects will happen there. All the retrieval of data will happen there in the boundary, leaving the core pure. Super deep one. It can ease the testing. It can ease the understanding of the code. But what's the trick? What's the problem? What's the difficult part? So the goal is this, to purify the most complex parts of your logic. Whenever there are complex business rules, try to model them as pure functions. But there is a problem. The problem is not time and random. This is stupid. This is not really causing problems. And everyone knows you shouldn't be working with files inside your core logic. It's common sense, right? It's filthy, right? The problem really is database and API calls. That's where the game really is. Now, most use cases that we implement should start with fetching more data from a data source. It's relational, non-relational, API, I don't care. Fetch data. You can fetch the data in the imperative shell. Remember, you can Google this, imperative shell functional core segregation. It's one of the more advanced design principles. So you do your read, your fetching of data, your impure fetching of data in the imperative shell, and then you call the pure function, F, which is blue, pure. Most of our use cases finish with writing data. Go ahead, write your data. But the data that you write, you will get from a pure function. This is the ideal world. You call a pure function, you get data, you store data. Okay? But this is just child play. This is not the real thing. The real thing is when in the middle of a long, complex function, you have to do another read. Sounds familiar? In a big workflow, if that and that and not that, and if that and if that, then do the API call to get that data. This is the real problem. Now, there is a refactoring exactly aiming to fix this problem, which is called split phase, one of the more advanced refactoring in the refactoring book. Split phase refactoring really means that you should split the processing into or more phases. Applying this technique to my case, I will isolate two pure functions, this and this, and I will bring this impure part to the surface. I will drag this in my imperative shell. Now, it's a nice animation, but it can mean 3 hours of work over there because you need to separate the flow into phases and then to pass some data. This is what makes it complicated. These structures that you pass from the first phase to the second phase. It calls for more design, calls for inventing new classes, new phase one result. Okay, it's a stupid name, but you get the point. You need to pass the data from the first phase to the second phase. But what do you get at the end? You get when you first enter a flow, you get to see this, which is describing maybe even all of that, you see, which is basically describing everything that happens, reading, writing, computing, writing, reading. And it's clear picture at the beginning, at the top level, in your facade, in your application service. Top level should state the master workflow and defer all the computation, the complex logic into pure functions that you test separately. So complex logic should go into pure functions, and the impurity should go to the surface, in the application service, in the facade, no matter how you call it. Okay, let me breathe air. Okay, now, what's really the problem where the blood drains is changing the state of objects. This is what makes most of our functions impure, not database and API calls, but changes in the state of objects. Excellent. So this naturally leads to immutable objects. Now, immutable objects. With your level of experience, I assume we all know, right? Final fields, of course, no setters, duh. Let's get more. Let me just share. Where is my code? Code. Come on, code, clean code. Yes, thank you. And pure place suggest, out. Pure immutable advanced. This is an do I have that? I hope I have. But I think this is already solved. Why is it solved? Thank you. Come back. There you go. This is an immutable object. Everyone agrees. It's final fields, no setters, everything taken to the constructor. Duh, basic stuff. But is it really immutable? Let me make it bigger a bit. Is it really immutable? So final fields, no setters, just getters. But there is a problem. The first thing you should ask is, how about this list? Well, I expose it there. So then someone evil can do this. Get numbers. Dot clear. Clear. You're dead. Your list is, so that's why even IntelliJ has a quick fix. I'm not sure if it's that time in which you realize that the tool is smarter than you. I felt smart when doing that, but then I realized IntelliJ had it. And I was like, oh my God. So this is it. No one can ever mutate your collection anymore. It will get an exception at runtime when it wants to change the collection, okay? But this is just one way to fix it. There are several other ways, including returning here. By the way, just I want to say, this is a factory method returning a decorator around the original list, which effectively blocks all the attempts to change. So you see, you are now the clear in the unmodifiable collection, which is the decorator class, throws you exception when you want to change anything related to the collection, allowing the reads to go through, but blocking the writes. Fair enough. There are other ideas that I will not finish, just sketch. How about returning an iterable? Ooh, there is no clear in the iterable. Interesting. Or returning a stream. Interesting. Or if you watch this later, please try the following. It's the most geek things I ever saw. Well, works for many cases. Anyway, let's stick with unmodifiable. This is the most widespread way to. Is this immutable now? Well, depends on the other. Let's see. Can other be changed? Oops. So what I mean here is to draw a line. Look how good this reads. IntelliJ teaches us our job. It says, master, you don't have a setter. Can we make this immutable? Right? This is like, you are almost there. I'm not sure if you really meant that, but let's make it immutable. It's good. It's good for your liver, for your health. Yeah, your kidneys will be happier if you make this immutable. Perfect. Now, all of that now, you can say that it is deeply immutable. There is one glitch, but I'm almost ashamed to show it to you. I'll leave you a moment to reason. Boom. I kept a reference to the list. But if I find anyone doing that, I will have a discussion one-to-one with that fellow. I mean, what are you doing? Are you hacking my state? What's wrong with you? The only way to really get around that is to clone the list. But I'm not happy with that. We are wasting memory. If you are in this game, you should probably look into immutable list from Google Guava. This is a state-of-the-art solution for immutable collections in Java. Java is an old language, 25 years old, very old language, right? Back in those days, 95, no one thought the immutable collections are a thing, right? So of course, the collections we have in Java are by default mutable, not like Scala, which by default has immutable, or Kotlin, immutable collections everywhere. Now, if you do want to jump onto immutable collections, this is my recommendation. If you want to take things seriously, all the persistence solutions know how to persist and to populate these. So it's quite a game if you want to play. Okay, now let's maybe explain again why immutable objects are good for your health. Why do they prolong your life and make you happier? They give you a happier family life if you work with immutable objects. Why? Let's imagine you are in a long debugging session, right? It's night outside and you are debugging, right? And then at some point you run into this line and you wonder, will this line really run? You don't want to go breakpointing. You know that's bad. It's volatile. It's bad exercise. So you want to realize whether this will run or not. Well, how you can determine that is to trace where X came from. Well, X is a field of data. Data came as an argument, so it came from G, and in turn it came from H. Perfect. And back in the H, it had the value 1. But if all this is mutable, of course, someone along the way can do this. But this is silly. The real problem is when you call a method with giving it a reference to your object. And 7 methods deeper, it changes the field. Sounds familiar? This is the game, the real game. That you have to trace whoever got a reference to that object before you. My God, and this is very hard in complex code bases. This is killing. There are 3 functions in here, 3 functions more in here, and in total there are 22,000 lines of code running for that use case. And somewhere in those 2,000 lines of code, someone does that. Of course, you can find the reference to the setter, but the next question is, will that setter run before me or after me? It's very, very complicated in real life to know where the data changed. But you know what? I once saw an even more horror movie. Just imagine you're calling a method without giving any argument. So you say to yourself, oh, it's safe, what can happen? Yeah, but that object kept a reference to the same object from 5 minutes ago. I'm not sure if you, this is the moment that you mute yourself and you enter the toilet and you start cursing, right? Maybe you take a cold shower, you come back out and relax. And you go to the garden. I see lots of gardens, and I know there are lots of gardens in your country. So yes, fresh air. It's very, very, very annoying, that thing. Good. But this is what awaits you if you allow the mutable data to live a long life. If a mutable object lives for thousands of lines of code, someone will have the idea, oh, let's change that. Someone in a long debugging session, someone during the night will say, let's fix this bug by setting the field. And afterwards you will, yeah, you get the point. Now let's convert this into an immutable object. If this is immutable, you don't care about the setters. You don't care about who you give your references to. Done. Love. Because it's easier to trace where the data comes from. There is actually an advanced analysis technique in immutable dot, with such an audience, I can try one more thing here. Let's do this. Okay. And now let's make this into a method. Right. And now here, right click. Actually, it's on analysis, something like code analyze. Data flow to here. What the heck is that? It tells you who created, where that object that you are referencing comes from. You can click on this one. Very advanced. You have to train yourself to here to actually use it successfully, but it's super, super interesting with IntelliJ. It can point you where this came from. It came from here. Anyway, you should play with it a bit. It's quite interesting. But anyway, the point is, it's easier to trace where the changes came from. Right. So the big deal of immutable objects is when they are when you have a long workflow like this with many. So immutable objects won't gain you anything for super trivial use cases. For 20, 100 lines of code, I don't care if you are using immutable objects or not. But if there is a very long workflow, like place order, imagine the place order flow, right? If there is a place order in there and you pass your mutable entity to many methods, someone will have the idea to mutate it somewhere, which is bad. So what I want you to do, when you enter a forest, a dark forest, there is that last place in which you still see the sunshine, that place in which the last time you see the sun before you enter the dark, that's where I want you to convert the mutable entity into an immutable data structure and enter the forest with immutable data structures. So if thieves kill you in the forest, nothing dramatic happens in the outside world. You are just had an immutable object with you. At the end of in the dark forest, in the hut of the witch, you compute the new thing that needs to be set in there, and you come back out with another immutable object. So you get the point. Value object that goes in is immutable. String that got out is immutable. Nothing bad can happen to the outside world in the dark forest, right? In the business rules forest, right? And you can create all these as pure functions without being sure that you don't change anything, right? So immutable arguments in immutable return values. This is what I want you to do for the complex flows, right? Now, immutability and pure functions are something from functional programming, and functional programming is famous for the use of tuples. Have you ever heard of tuples? Tuples everywhere, and I've seen it as big. The problem with tuples, oh my god, I'm not sure if I have somewhere on my disk some code. It's incredible. It was a tuple over tuple and another tuple, and then string int. And I was looking with when I go to companies to do refactoring, I get samples from their code base, and I ask them, what is that tuple meaning? And they say, well, a string and an integer. God. The problem with tuples is they are lacking names. They are lacking abstractions. So we have to have guts to create a new class. So tuples are good if they are used in a single method, and if they never escape a method or they never escape through your public API of that class, maybe your internal garbage is your problem. But tuples should be explained if they are visible as classes with fields, right? Oh, I forget to do one thing. Oh, yes, I have time for that. Good. Lombok. Yeah, Lombok. If you are so happy with Lombok, let me show you another one. Programming funny? Lombok. Oh, Lombok. Java is a very old language, 25 years old, right? So very verbose. So when you get tired of Java's verbosity, you generally face a decision. You became a scientist, a hacker, or you start cheating Java with Lombok. This is a sad reality. We have to live with Java, right? But many, including me, think that Lombok somehow rescued Java. There was a movement to leave Java a while ago, but then Lombok came, and nowadays, 9 out of 10 projects that I go to consult or to train use Lombok extensively. So let's play Lombok on this. All of you know of data, but did you know about value? Very interesting, which makes all of the private final also useless, right? This is out of the box here. I forgot to do one thing though. You see, whenever you have a constructor for an immutable object is an opportunity to put validation in place. Such as, for example, others should never be null. Let me come back to the clean Java solution first. Here. Now, how do you validate this is not null? The simplest form I know, RNN, control space twice, control shift enter. What the fuck are you talking about? Again, RNN, control space twice gets you the static functions. If you press enter, you are almost there. But no, I said Control Shift Enter. And now the angels. Ave Maria. My friend, do you know who told me that? It was Nikolai. One guy, in March, emailed me. I work in IntelliJ data team. I said to myself, oh, so what? We are all using IntelliJ. But then I realized that he is developing IntelliJ for 15 years. Nikolai Chasnikov is one of the leads of IntelliJ idea in JetBrains. Then I realized, what? Oops. And he told me about this trick. When you are about to autocomplete a function, if you press Control Shift Space, you will wrap the expression with your code. Super cool stuff. Super cool stuff. You know what I answered him? I've reached the source. Oh my God, I'm there, right? Good, but the thing is, you want to do these tricks to enforce validity of your model, which is very cool. But then let's switch to Lombok. Yeah, ver, as I mentioned. One other question though. Let's actually do this. This is done already. This nullable thing, you can do it right here on the other, not null, non-null, which will check the null. Unfortunately for this baby, I don't have an alternative. There is no way to do that with Lombok immediately. This you will leave because you want to have a decorated list, but these are redundant, these are generated. ToString is also generated. You probably, if you never knew about Lombok before, there's getters, there is hash code equals ToString and constructor form. Very good. But nowadays, if you say to someone Lombok, he will say, no, my friend, wait for Java 15. Record. What? Now the Kotlin developers are so happy, right? Data classes, case classes in Scala. Here you are. Finally, we have this. Record. Done. Okay, so it's there. It's there already. It's in the Java language. It comes this autumn when the Java 15 long-term support will be out. Java 17, sorry. 17 will be long-term supported. So probably this time next year, their companies will dare to jump on maybe 1 year extra to get you Java 17 in production. So Java records go in the same direction. So the language is changing towards immutable objects also. But we did this together. Do we want to spend much more? But yeah, the thing is that the conclusion in the end, how do we change an immutable object? What do you mean change it? You can't change it. No, but what if I want to get a similar object, but with a different x? Different x. You can't do set, of course, but you can do with. Have you ever heard of withers before? Withers. With x, and you say the new x2. And this, the only possibility is to return you another object, of course. Interesting. So let's create the method, which will new x will create the new immutable with the new x, the numbers, and the other. And you can change the objects by creating new instances. This is the only way you can do it with immutable objects. But this gets people ideas. Oh, so we can change them. Can we? Now, take a look at this one. You call a function, you give it the argument. Now, folks, the easy part just finished, just now. Now comes the immutable mindset. Not immutable object. Immutability is a mindset. Data, you take it as an argument, and because you have to change it, you return it back. Will this work? Yeah, you can change whatever you want in that function. Perfect. And you do this all the time. Oh, yes. And then you wonder who changed field X. Let the dogs out! Let the dogs out! This is the question that you will ask. Who changed field X? You don't know. You don't know. You are back at where you were previously with immutable object, more or less. But the mess is still there. How to fix it? How to fix it? Well, First of all, you should not reassign variables. Make sense? Final variables. But this is a brutal way to fix the problem. I personally look out for the underline. The underline means in IntelliJ that a variable is being reassigned. Look, when I did this, the variable I like to call it abused variable, reused, recycled. I don't want recycled variables. You see, now the underline is gone. Immutable with x2. Okay. So avoid reassigning variables, but this is big. This is like, what? You can't just, the people, developers, your team needs to understand this and follow this. Now, the real problem, however, is another one. The problem is that your immutable object was so big, had maybe too many fields. You see, I've seen, you can imagine how much horrors I've seen in my life, but consulting for, I've seen entities with more than 200 fields. GPA entities with more than 200 fields. At which moment someone of you says 200, come on, that's a game. 1,000, 200 fields, right? You can live, you can survive with entities with 200 fields, but with an immutable object with more than 5 fields, it's very hard to live. So immutable objects inherently need to become very small, because anytime you change something from it, you need to create another object. So immutable objects by themselves will force you to design more, to break them further. So one way to avoid this situation is to create another object, XYZ, which is computed all at once as a single whole. You see? So instead of calling 3 methods here, 1, 2, 3, you call a single method that gives you the XYZ as a whole. But then you ask, what is this, my friend? Is this assignment? Oh, is this a public field? Are you out of your, do you want to get fired or what? Let's see. Should entities be immutable? No. Your persistent model, your entire persistent model is too difficult to make it immutable. Too difficult. There is a niche in more than 100 companies. I've seen a single company until today which had their entire persistence model immutable. They were using immutables from Google. There is a library for that. And they were persisting in Mongo, not in relation. There is no way that Hibernate can ever work with immutable objects. By the way Hibernate is built, they want to set fields. They won't ever work with final fields. So instead of trying to make all your entity model immutable, I want you to make parts of it immutable. So to extract parts of your objects as immutable components, leaving the root entity mutable. What do I mean? The time is pressing, but record no. Let's come back to the Java solution. Imagine this is an immutable object. I can convert this, I can put this into the database with a relational database. With Mongo, is no problem to have immutable objects. Hibernate is angry with that. Hibernate, we can convince Hibernate to persist this into another entity. Let me show you. Entity, customer. You can do embedded and reference private, immutable, immutable. This moment, the X numbers and others will become columns in this table. There is one trick you need to do though. You need to do a constructor just for Hibernate. This works. I've used this in my projects just for Hibernate. And you can persist this in your entity. You can get effectively, it's not strictly immutable, but you still don't have setters. So it is effectively immutable. You see? You can decompose your larger entities, leaving them mutable, but you can isolate some immutable leaves like full name, interval, money, and you can persist those in your database. Okay? This is how persistent objects can be used in real life. This plus the butterflies. The butterflies are those objects that live a very short, happy life. Those objects that you create part of a workflow but never get persisted. They just move from here to there and you write logic on top of them. Okay, little bits of data moving together. All of those little objects all of those objects that are never persisted but just used to build logic, all of those objects should be always immutable, always. All right, so the big deal, again, to summarize, is when we have large workflows, complex business flows. Okay, that is when you want to have immutable objects, just to be sure that no one changes them along the way. Okay, 2 more slides. Avoid immutable objects. If you indeed are trashing millions of instances per second, if you are doing a lot of withers and changing them and recreating them quite too often, don't. If you get to cloning a lot of collections, these are killing for your garbage collector. These result in a malloc to get the array allocated in the memory. It is criminal for garbage collector. Then there is no use in making your data transfer objects, your JSON objects, to make them immutable. There is no use because you don't write logic, I hope, based on the DTOs, right? And for trivial logic, it's just overkill to do immutable object, to do immutability. So, last slide, takeaways. Every complex logic you have, you should extract it as pure functions. Why? Easier to understand, no temporal coupling, easier to test. And this is what you really want. Easy to test without mocks, right? Those pure functions, not only they don't talk to database, but they are using immutable objects, okay? Then this idea of separating the functional core versus an imperative shell that does all the round trips to the external world, and to pull everything which is impure, every database or remote call, out in the imperative shell at top level in plain sight in front of you at the entry point. Never change a field in there. This will happen during the nights, right? Debugging. If I just change that field, then it will work. Don't ever do that. Instead, maybe convert everything to immutability and go ahead and compute and return. Immutability is a mindset. Remember this guy? And you should never mutate arguments, variables, or collections. You should never, I don't know, change collections. You can compute new collections using stream API. And immutable should be those things which are the data that is used at runtime to build the logic or parts of your persistent model. That's the final slide. Good. Now, questions, doubts. There was a lot of strong statements in this short presentation. I dared to do that because I looked at your experience level and I wanted to be only over 10 years. Like, whoa. So,
thank you very much, Victor. Before we start with the questions, I'm going to stop the recording. So I'm stopping it now and saying thank you very much for this very enthusiastic presentation. Okay.